Question 1 is simply asking us, we need to calculate the distance between the start of the town and the end of the town. So where is our town is located? You can see town is here. The start of the town, here is the end of the town. We need to calculate the distance. What is given to us? Speed is given to us on y-axis and time is given on x-axis. So how we can calculate distance? If we need to calculate the distance from the speed time graph, so simply distance is equal to area under speed time. Speed time graph is equal to distance. So this is equal to distance. So this is a piece of information or the concept you need to answer this question. We simply need to calculate area under this line. So you can see this is simple, a rectangle. So we need to find the area of this rectangle. So this is how we can answer now. So area under line BC is equal to distance, and this is our final answer. So here is our final answer. Let's move on to part B now. For part B, we need to calculate acceleration of the car. So first thing we need to calculate is acceleration of the car between C and D. So where point C is located? Point C is located here. Point D is located here. We need to find the acceleration. So let me draw the line here so it is easy to see. Here we need to find acceleration between point C and D. How we can find acceleration between point C and point D? As you can see here, the speed time graph is given. So how we can find acceleration? So in this case, gradient of speed time graph, velocity time graph is equal to acceleration. Here we are talking about a straight line motion, so it means velocity and speed, you can treat them same because direction of velocity is not changing, body is just moving in a straight line. Okay, so how we can answer now? How we can answer? So the first thing we need to understand is coordinates of these points. We can simply write down is 42 and 13, and the coordinates of point D we can also write down 54 and 31. Now we just need to simply find gradient. So this is how we can answer. This is our final answer. Simply just plug in value, nothing much here. This is our final answer. So now next one is part C. Part C is asking us show how the graph shows that deceleration of the car has the same numerical value as acceleration. So again, we need to understand is how we can find acceleration and how we can find the deceleration. So let me highlight first of all. You can see here between A and B, the car is decelerating, and between C and D, car is accelerating. How they can have the same numerical value? They can have the same numerical value if they have the same slope or they have the same gradient. So here is what you need to understand before we can answer this question. So again, gradient of velocity time graph, it can be equal to acceleration and or it can be deceleration, So if the gradient is positive, it means that is acceleration. If the gradient is negative, that is deceleration. If you have understanding of this one, then it's quite straightforward. And total marks for this part are only one mark for this part. So here is how you can write your final answer. Let's try to answer question 2 now. For question 2, it is given to us there is a one package, and this package is raised by motor. So here is the package, and let's say this package goes to this point. We can also draw package here. Part A is asking us, we need to calculate the increase in gravitational potential. So the mass of the package is given. The mass is equal to 36 kg, and the vertical height is also given. How we can calculate the gain in gravitational potential energy? Simply the gain, for example, the change in gravitational potential energy, that is equal to mg delta h. So the g at IGCSE level, we can write that is equal to 10 Newton per kg. Now simply we need to just use the formula and we can find increase in gravitational potential energy. So we can also write down as it is the vertical height. So you can see the vertical height is given. So simply we can just plug in values and we can find the answer. Here is our final answer. Quite straightforward one. Just we need to understand the formula and we need to find out the right information to plug in. Next question, part B. As you can see, the time for this vertical height is given to us. Question is asking us calculate power. So the main thing we need to understand is what is the relationship between power and energy. So the power is simply is equal to energy over time. Over time means the energy transfer over time. If we have this understanding, we can simply answer this question now. Because we already have gain in gravitational potential energy, time is also given and we can find answer now. So here is our final answer. So we need to be careful. Just read question carefully. That's all. And also don't forget to write the units. Let's move on to next one now. Okay, next part. Part C is asking us to use law of conservation of energy. Explain how we can use law of conservation of energy in this given situation. So it's quite straightforward one. So electrical energy means the total energy in the law of conservation of energy. For example, we simply understand total input energy has to be equal to total output. Total input energy has to be equal to total output. So simply total input energy has to be equal to total output. Total output energy. So electrical energy, this is our input energy. So electrical energy is the input. So electrical energy is the input because this is the energy provided by motor. So electrical energy is our input and our output is the gain in gravitational potential energy. So this is gain in GPE and plus thermal energy means this is energy that is equal to work done against friction. Okay, so that's all. This is we can simply write down. If we write these points, we will get 2 marks for this question. Okay, next one. Assume the power raised the package is constant. So this is very important piece of information, means the power is constant and the package mass is greater than 36 kgs. Same height. We are only changing the mass now. So suggest and explain the effect of this increase in mass on the operation of the conveyor belt. Operation means it will take longer time, it will take shorter time, its speed will increase, its speed will decrease. These things what it means by operation of the conveyor belt. So how we can answer? First thing we need to understand is the effect of. So the first thing we need to understand the effect of increase in mass. So if the mass increase, we simply understand the gain in gravitational potential energy that will also increase. So if this mass increase, the gain in gravitational potential energy will also increase. So this is one thing we understand. Now energy is equal to power times time. We can also write down in this form. So the power is constant, means the power of the motor is constant, but energy has been increased. It means time taken will also increase. So this is simply you can write down. So it will take longer time. If you write down these points, you will get full marks. And that's all for question number 2. Let's try to answer third question now. For third question, 2 train engines are given. One is moving and one is stationary. So this is moving engine and the other one is stationary truck. Now what we need to calculate? We need to calculate the momentum of the engine before collision. So, and the engine is traveling at this velocity and the mass of the engine is also given. Now, how we can calculate momentum? So, it's a very simple concept that momentum is equal to product of mass and velocity. So, we have mass, we have velocity, just plug in and you will get your answer. So, this is how we can do, and this is our answer for this question. 0.16 kgs meter per second. Let's move on to next one now. For next question, again we need to understand the mass of the truck is given now. This is the mass of the truck. This is we need for part B. Now we need to use principle of conservation of momentum. So what is this principle? First try to understand what is principle of conservation of momentum. This principle simply tells us for any collision, momentum before is equal to momentum after collision if no external force is acting on the system. Means external. If no external force is acting on system, we can say is principle of conservation of momentum acting on system. This is for part B. We need to calculate the speed of the engine, joint engine. This is very important. Joint engine, also we can say the engine and truck, they stick together. So it simply means I will just draw one basic drawing to show this moving engine. So here is our moving engine. So this one is moving engine. So they stick together. So how we can answer this? So first thing we need to understand, momentum before has to be equal to momentum after. So if we have this understanding, we can find the answer. Momentum before, as this is what we have calculated in part A, and in part B, as truck and engine, they stick together, so we can add their masses, so they will have a same velocity. So sometimes in question this will be given to you, the V, this is the common velocity, means they have the same velocity. So we can also write down this is the common velocity. Now just do simple mathematics and we can find the combined speed. That's all for this question. Question 4, and this question is about solar panel. Question is simply asking us select and explain features of the solar panel to maximize the final temperature of the water. Here is copper pipe that is painted black. We are also using sheet of glass, and here is also metal sheet that is also painted black. And insulating material we are using under copper pipe and air trapped. And so how these features, for example, how these features means why we are using copper pipe, not using any other pipe made of rubber, pipe made of plastic, why we are not using those type of material, why we are using only copper pipe. There must be some reasons, scientific reasons, logic behind. So why it is painted black, why it is not painted white. And insulating material, why we are using insulating material, not conducting material. Air trapped, if air is trapped, what is benefit of that? To increase the temperature of hot water. And also here we have metal sheet, why it is painted black. So these are the features, and now we need to select them, means we need to mention the feature, and also we need to explain, means what is its role in increasing the final temperature of the water. So let's answer this question now. So this is how we can answer this question. So you can see here, first of all, I have mentioned copper pipe. This is one feature, and why we are using copper pipe? Because it is a good conductor of heat. If material is a good conductor, so good conductor We need to understand what good conductor means. Good conductor simply means that material can conduct heat quickly and easily. Conduct heat quickly and easily. So this is benefit of good conductor, quickly and easily. The second feature, black surface. Why the surface of copper pipe is black? Because black surfaces are good absorber. It means they can absorb more heat, and they are poor reflector. It means they will reflect less heat. The third feature, trapped air. We can also talk about this one. If the air is trapped, it means there will be less heat loss due to convection. And fourth one is insulating material. Why there is insulating material under this copper pipe? Because it will reduce heat loss. And fifth one is glass. Glass, here you can see we are using this material, and this one is made of glass. Why we are using glass here? Because glass produces greenhouse effect, mean it stops radiation from escaping. For example, if the radiation go after glass, it will be reflected back. So means here glass produces greenhouse effect, and due to greenhouse effect, temperature of copper pipe, or means the temperature of water inside copper pipe, will increase more. So this is how we can answer, and this part A has 4 marks. Let's move on to part B now. Part B is about calculations. So what is given to us in this question? It is given to us mass of water is given, and the temperature rise is given. Means this is delta T is given to us, and the specific heat capacity of water is also given. So the C is given. So let me explain you one very important point, means the key concept. Let me explain to you. So this key concept we can simply understand like this. Let's say the 4 rays of light, 4 radiations are falling on this solar panel. So this is our solar panel. So how many of them are reflected back or not absorbed? So according to given informations, if 4 radiations are coming, so only 1 is absorbed. It means that only 25% is absorbed, or we can say 1/4. Now this is very important, because this is kind of common problem for many students to find out energy incident. They can find out how much energy is absorbed by water, but sometimes they just get stuck. They don't know what's going on. So if you have this idea, you look at this diagram, you will be quite confident to answer this question. So let's answer now. This is just simple use of formula mc delta T. This one is the mass, here is the C, and here is delta T. Delta T means that 38 minus 16. So we got 22. We don't need to convert to Kelvin in this case, because the change is the same. The change is the same. Delta T is the same in Kelvin and also in Celsius scale. So if you calculate, this is the amount of heat absorbed by water. Next one, energy incident. As I explained to you before, if we need to calculate energy incident, we just need to multiply by 4, because this one is the 25%. We need to calculate 100%. So we just need to multiply by 4. So if we multiply by 4, this will be our final answer, the total amount of energy incident on the solar panel. So you see how we just need to find out how much energy is absorbed and the total energy, then we can just multiply by 4 and we can calculate. Let's move on to next one, part C. We don't need any calculations, so this question we can just do without any calculations. Question is asking us list and explain 3 pieces of informations if she needs to consider in order to make her decision. And we need to help this person now so she can decide easily. So first thing, for example, when you are going to install solar panels, we need to consider is the light, the sunlight is enough there or not. The second thing, the cost is very important. Also, we need to consider our needs in the solar panels. How many solar panels we need to install so it can meet our needs. So these things, if we have in mind, we can answer that. Let's move on to our answer. So this is how we can answer. First thing we have to consider which direction roof faces mean. Is the light is enough there or not? If there is any shade, if the roof is shaded, it means it's not good to install solar panels. We also need to estimate the output of the panels. How much is the output? Can it meet our needs or not? So here is also the next one, household needs. So we also need to consider. The last thing we have to consider, the cost of installation. So do we have enough money to install or not? The last part of question number 4. This question is simply asking us what is meaning of nuclear fusion. Nuclear fusion. So nuclear fusion simply means that two small or lighter nuclei, they combine together and they form a big nuclei. Big nucleus, simply I can say. This is mean lighter nuclei combined to form heavier nucleus. So this is how we can answer. Lighter nuclei join together to form heavier nucleus. So this is how we can answer question number 4. Let's move on to question 5 now. Question number 5. Question number 5, you can see here we have a piston. So this is piston and here is cylinder. So this is cylinder. And also this length is given. This is 100 centimeters. And pressure gauge is also installed on this cylinder. Now what we need to answer? We need to describe the motion of the molecules of the gas. So the value of P is given to us and cross-sectional area is also given. So how we can answer part A now. Part A simply is asking us describe the motion of the molecules. Motion of the molecules simply, this is a very common type of question. We need to understand molecules move randomly and they collide with each other and also they collide with the walls of the cylinder. So this is very simple one we can answer. The next one, use the idea of momentum to explain how the molecules exert a force on the walls of the cylinder. So first thing we need to understand using the idea of momentum and force. So we need to understand what is relationship between momentum and force. So force is equal to delta P over delta T, means simply rate of change of momentum is called force. This question has 2 marks. So let's try to answer how we can write a proper answer for this one. So here this is how we can write the final answer. Now you can say the proper answer. Collisions with walls will cause change in momentum of molecules and rate of change of momentum is equal to force. If we write these 2 points, we will get 2 marks. Next one. Here is our part B. Question 5, part B. Question 5 is asking us, now the cylinder is, the new length of the cylinder occupied by the gas is only 40 centimeter. Before it was at 100. Now the cylinder is at 40 centimeters. Means the cylinder is at, means the piston is at this point now. And this distance is 40 centimeters now. So, and in other words, we can also say volume is decreased. Means the volume has been decreased. So volume is decreased. So this is one thing we need to understand. Volume is decreased. So it's asking us calculate the new pressure of the gas. So this is quite straightforward one. We need to use P1, V1 is equal to P2, V2. All the informations are given in previous part. We just need to plug in values here. One thing we need to understand is that as the cross-sectional area is the same, so we simply understand volume of a cylinder that is equal to cross-sectional area times L. So if area is the same, so we can simply consider L. This is simply Boyle's law, very common formula. This is the formula you need to remember this one. So this is P1 V1. So you can see this is the volume actually. Even here we just use L because on both sides this one will be cancelled because this is the cross-sectional area and this one is the L. So here again this is the volume, this is V2, and what we need to find out, we need to find out P2. So if we just multiply and we simply solve, we will get our final answer. So this is new pressure. It has to be increased than before because as volume decrease means PV is equal to constant according to Boyle's law. So this is simply our Boyle's law. PV is equal to constant. So simply you can see if volume decrease, P has to increase. Let's move on to next one now. Explain in terms of the behavior of the molecules why pressure has changed. As I mentioned before, as the volume has been decreased now, this is very common misconception among many students. They think that when the volume is decreased, it means the speed of molecules increases. No, speed of molecules only increases if the temperature increases. So in this case, temperature is not changed. Given to you temperature of the gas is unchanged, it means the speed of molecules is not changing. So now the space has been decreased. Now it means the molecules will hit the walls more often or more frequently. So this is the keywords you need to understand. If the volume is decreased and temperature does not change, it means molecules will hit the walls more frequently. So this is the point you need to understand. Now let's try to answer how we can write our final answer. So here is our final answer. Molecules collide with the walls more often or more collisions per second. So if more collisions per second means more people they're pushing the walls at the same time, so it means greater force per unit area. So more often they apply force again and again. So it means greater force per unit area. If the greater force per unit area, so simply we understand P is equal to F over A. If the force increase, it means P has to increase. So this is how we can answer question number 5. Next is question 6. Question 6 is also kind of typical question at IGCSE level. Let's try to answer this question now. The first part simply is asking us, we need to draw the pattern of the wave fronts after the wave has passed through the gap. So how we can answer this one now? So before we answer this question, we need to understand this is the wave front. So this line, horizontal line, this represent wave front. And the distance between two wave fronts, this is equal to lambda, means the wavelength. So this is wavelength. So we need to be quite clear about this. As we can see here, the water is on one side and after it crossed the barrier there is also water, means the medium is not changing. If the medium is not changing, let me write down the frequency that is equal to V over lambda. Frequency, we need to understand it depends on what? Frequency, it depends on source, and velocity, it depends on medium. It means if the medium is the same, speed of wave is the same. Speed of the wave is the same. If the speed increase, lambda also have to increase. If speed doesn't change, wavelength will also not change, and also vice versa. If the speed decrease, wavelength also decreases. Now as the medium is not changing, so the wavelength will not change because the speed of the waves will not change. So this is how we can answer. So what we have to be very careful is over space, actually space between these lines. It has to be same as before barrier, and it also has to be same after barrier, because wavelength here, let's say speed is v1 here and speed is v2 here. In this case, v1 is equal to v1, v2 is equal to v1, and lambda 2 is also equal to lambda 1. The second thing we need to understand is that we need to draw at least 3 wave fronts, not 1, not 2, at least. So how many wave fronts you have to draw? At least 3 wave fronts to get full marks. Part B is simply asking us calculate the frequency of the wave. So what is given to us? The wavelength is given to us, means the lambda is given. So its value is given in centimeters, and the speed is also given, v is given in centimeters. We need to simply calculate frequency. The units, you can see the wavelength is in centimeters, speed is also in centimeters per second. So simply we can calculate frequency. So this is how we can calculate frequency. So simply frequency is speed over wavelength. So simply centimeter will be cancelled with centimeter. We will get, this is our final answer, 8 Hertz. We can also write down, because this has 2 significant figures, we can also say 8.0, means we can also write down this is 8.0 Hertz, or we can also say per second. This is what happens to the frequency. We have already discussed frequency depends on the source, and frequency is equal to v over lambda, as the source is not changing, so it means the frequency is not changing. So this is our answer, no change. Here is the last part, part D. Let's try to answer part D now. So what this question is asking us, this is the first thing we need to understand. Explain in terms of diffraction. May pick up low frequency radio signals but not pick up high frequency radio signals when the car is traveling behind a hill. And the physics we need to understand to answer this question is simply diffraction. Let's say these waves are coming and we have a barrier here. If the gap size, means this gap size, if this is almost equal to the lambda, to the wavelength, when the lambda is almost equal to the gap size, so gap size means this is the gap size. So in this case we have significant diffraction. So this is one thing we need to understand. Significant diffraction occurs when these two are almost equal. So there will be significant diffraction. But if we decrease the sign, if we decrease the gap size, now let's say we have the same waves, they are coming. Now if the gap size we decrease, so in this case there will be more diffraction. If the lambda is smaller than, if the lambda is bigger than, means the lambda, the wavelength, for example, if it is bigger than gap size, there will be more diffraction, bigger than gap size. So we can say more diffraction, or waves will bend more diffraction, waves diffract more. As we understand, the size of the hill is very big, so it means if the wavelength is bigger, there will be more diffraction. So we will simply say if the wavelength is longer lambda means that in this case there will be more diffraction and it will be easy to receive signals. So if we have understanding of these points, then it's quite easy to answer this question. So let's try to answer how we can write a proper answer, or our final answer. So this is how we can write down our final answer. And we need to say that is the low frequency. If the frequency is lower, it means wavelength will be longer. If the wavelength is longer, it means there will be more diffraction. So that's the reason it is easy to pick up low frequency signal as compared with higher frequency signal. signal. So that's all for this video, and I hope this video will help you to understand question 4, question 5 and question 6. That's all for this video, and remaining 4 questions, I mean question 7, 8, 9, 10 and 11, means 5 questions I will cover in next part. Here is our first question, question number 7. Let's try to answer this question now. As you can see here, first of all, the part A is simply asking us state the name and purpose of component X. So here is component X. Component X is here. So simply this is a very common type of resistor. This is called variable resistor, and its purpose is to change the resistance. Mean we can change the resistance of this resistor. And so that's all what we need to understand, and here is how we can write our answer. Variable resistor, it can vary or it can change resistance. When we change the resistance of the circuit, it means current in the circuit also changes. It is given to us the heater is designed to work from a power supply. I mean, this is the voltage needed for the heater, and the power rating of the heater is also given, that is 4.5 watts. Now the question is asking us by considering the current in the heater. This is a hint for you, considering the current in the heater. So this is the hint, very important information for you. Calculate the resistance of component X when there is correct potential difference across the heater. So this is our heater. So the potential difference across this heater is 3.6 volt. So this is 3.6 volt. Its power rating is also given to us, but don't get confused with the voltage of the power supply. We need to consider voltage across heater when it is operating normally. So now simply first thing we need to find current in the circuit, and then we can use that current in the circuit to find the resistance of variable resistor. Let's try to see how we can answer this. And so this is how we can answer this question. So first of all, what we have done, we have calculated I. So you can see current. So we have calculated, and this is for heater. So our answer is 1.25 amps. So now when this switch is closed, so current in this circuit is 1.25 amps, and same current is passing through this resistor, same through heater, because they are connected in series. So what is the voltage across component? And this one is the voltage across heater. So I will simply say this is V for heater. So now we have V for heater, and the total voltage, this is the EMF of the battery, or the total voltage across battery, and we got this is the voltage across X component. I will simply say this is Vx. Now we have Vx and we have I. Simply we can calculate resistance of X component. So here is resistance of X component. Now let's move on to part C now. Sometime after the heater is switched on, the ammeter reading has been decreased. Ammeter reading has been decreased. So you can see if the reading of this ammeter goes down, what can be the reason? There are two possibilities, because this current in the circuit, I will say that I total is depending on two things. One thing, it is depending on the total voltage, mean EMF of the battery. We can also write down this is the EMF of the battery. Or it is depending on R total in the circuit. So this can go down or this can go up. So if you have understanding of this, then simply we can answer. So first thing, the battery running down means EMF decreases, as I mentioned here, or resistance of heater increases. That's all. This is how we can answer question number 7. Next one is question 8. Is quite interesting question. This is based on logic gates. Question number 8. First thing we need to understand is that the name of these logic gates. The name of this logic gate is NOT gate, and this gate is AND gate. AND gate. So these two names are very important. And here we have relay, and next one is lamp. So we need to complete the table by giving the outputs of A and B. So outputs of A and B are given. So let me little bit explain to you about NOT gate. For example, if the input of NOT gate is 1, its output will be 0. If its input is 0, output will be 1. And for AND gate, if one input is 0, another input is 1, output will be 0. If both inputs, let's say this one is 1 and the other input is also 1, then in that case, let me again write down. Maybe the second part will be hard to see. Let me write down. If this input is 1, this is also 1, only its output will be 1. So this thing we need to understand. Now let's move on to next one. What is given in the question? That is very important. We have to be very clear. So many students, they will miss this point and they will get confused what's going on. Even they understand NOT gate and AND gate. So it is given to us the output of temperature sensor. Output of temperature sensor is logic 1 when there is a high temperature, raise in temperature, and output of light sensor is 1 when it detects raised light levels. Output is 1. And so based on this, we need to answer output of A, output of A, and output of B. So the output of A, for example, this is the first thing we have to be quite clear. So let's try to understand. I no need to write again and again, so you can see from here. So output of light sensor. If the output of light sensor is 0 and here output is 0 here, if this is 0, so it is NOT gate, this has to be 1. So that's the reason we wrote here this is 1. Now the next thing what we need to understand is if this is 1 and this one is 0, what is the output? That has to be 0. Next thing, when output of light sensor, this is 0, so this again has to be 1. This has to be 1. Now when this is 1, this is 1, that is also 1, means when this is 1 and here is also 1, so this has to be 1. And same as when this is 1, for example, this is 1, here has to be 0, so this is 0. And the next one, so we see we have these two, 0 and 0, mean this one is 0, this is also 0, so this will be 0. And the last one is 1, so the output, if this is 1, this has to be 0. And here is 0. Now we need to consider these two now, 1, 0, so means when this is 1 and this is 0, so the output has to be 0. So here is what we got, output of B. I hope it is quite clear to you now. Next part is simply asking us state the condition under which the lamp is lit. Dark. If dark, the output of this one, output is 0. And when this is bright, output of light sensor is 1. And when temperature outside is cold, output of temperature sensor is 0. And when it is hot outside, means the environment is hot, output of temperature sensor is 1. This lamp has to be on. Simply speaking, when output of B is 1. So how this output can be 1? This is only possible if this input is 1 and this input is also 1. As we know, here is a NOT gate, so this input has to be 0. So simply we can say it has to be dark and hot. So that's the reason our answer is dark and hot. Suggest why B is connected to a relay. So we need to understand the logic. Let's say this is our circuit and relay is here. This is just a coil, and here we have circuit like this. Let me draw in a little bit different way so you can see the logic. And let's say here is a battery and here our lamp is attached like this. So this is low voltage circuit, low voltage circuit, low voltage circuit, and this one is high voltage circuit. High V, I will just write down high voltage circuit, high voltage. We cannot provide enough power because this is low voltage circuit. Why? Because B is connected. So B is in this circuit. B is connected in this circuit. And this circuit has low voltage. So the voltage is not enough. So we use relay. So relay will switch on, and other circuit means relay will switch on high voltage circuit. So that is the simple reason, and this is the purpose of relay. This is how we can answer part C. Question number 9 now. Question 9. Question number 9 is asking us describe what happens to the charges in a metal point on a ball as the positively charged rod is brought. So we have ball is here. So this is the ball. I can highlight for you here. And this rod is positively charged. Means it has net positive charge. Means lack of electrons. So what will happen? Simply understand, if I draw this side, I can say this is positive, negative, positive, and negative. So these electrons, they will move towards this side. The side next to positive rod will be more negative, net negative charge on one side and net positive charge on other side, because electrons will move from this side to this. So we have more electrons on this side. So this is what we need to say, that electrons or negative charges move towards positively charged rod. Explain why this happened. We need to explain the reason now, given that the ball is uncharged. Means uncharged simply means that it has same number of positive charges and same number of negative charges, or we can also say is neutral. So why this happens, here is the reason for that. Negative charges, for example, they are closer to the rod, and attraction between opposite charges is greater than repulsive forces between like charges. So what exactly it means? So simply means that this side, as we have discussed, become more positive and this side become more negative, and this rod was positively charged. This rod was positively charged. Now we need to understand the Coulomb's force or attractive force between charges. Now you see the negative charge is closer to positive charges. If we compare this one, the positive charges and positive charges, they are far away from each other. So this is force of attraction between opposite charges, and here is repulsive force between same or like charges. So in this case, force of attraction is winning, force of attraction is greater than repulsive force, because this distance is shorter than this distance, means the distance between same charges. So that is the reason. So the next question is very simple one, is simply asking you state the unit. Electric charge has this unit coulombs, and often we write down capital C because this is after name of scientist. So this is how we can answer this question. Question number 10 is about radioactivity, but this is a kind of combination of electromagnetism and radioactivity. So first of all, we need to understand if we have magnetic field that is into the page. So this symbol cross means that into the page. So the cross is telling us that magnetic field is into the page. So we can simply draw these arrows. Now, first thing we need to understand, if gamma particles are coming, gamma particle, so we simply understand this particle will just go in a straight line like this. Next one, we need to understand if alpha particle is coming. Let's say alpha particle is coming. I will just write down alpha particle. Now we need to use Fleming left hand rule. So what we need to use is Fleming's left hand rule. Fleming's left-hand rule. If we use Fleming's left-hand rule, so the force on alpha particle means the magnetic force on alpha particle, that will be upwards like this. And if we have beta particle, this has opposite charge, so the force on this one will be in opposite direction, somewhat like this. So we can see at A the number of counts are only 32 counts per minute, and at B their number of counts are a lot. And at C we can also see the number of counts are not too many, less than B. So this is when radioactive source is totally removed. So the readings, this almost stays same. So we can simply say these readings can be due to background radiation. So these counts are due to background radiation. So simply I will write down these are due to background radiations. B, you can see it dropped to this number, and this also dropped to this number. As there are readings at this point, it means the gamma particles are reaching this point. C, it means beta particles are reaching this point. So this is all what we need to understand, and is asking you deduce the type of emissions. So it means gamma and beta particles are present, and also radio means the background radiations also there. So we have to first of all deduce the type of radiations, and then we have to explain our reasoning. Our reasoning will be based on Fleming's left-hand rule and charged particles in a magnetic field. So let's try to answer how to write a final answer. And so here is how we can write our final answer. Gamma rays, as they don't have charge, so they just go in a straight line. Gamma rays are detected at B, as I explained to you before. They are detected at B because they are not deflected by magnetic field. Beta particles have negative charge, and they are detected at C, as here they are detected at C because they are deflected by magnetic field because they have charge. And the experienced force that is towards the bottom of the page means they go like this. So they go like this. This one is better one. So they go like that because the force on them is towards the bottom. So that's all. And at point there are background radiations. So this is point A. So only background radiations are detected here. So background radiations. Let's try to answer last question now. Complete the parts of these alpha particles. So first thing we need to understand, as this alpha particle is between them, it will go almost in a straight line. It is coming right on this nucleus, so it will bounce back, it will be deflected back, and this angle will change. So just we need to draw the straight lines. This is how we can draw. Let's move on to the last part of this paper and this question. Part B. Part B1. An atom consists of very tiny charged core. Means nucleus. Charged core simply means that nucleus. So this is what we call is nucleus. It contains almost all the mass of the atom. State the result of the experiment. Okay, so we need to state result of the experiment. Let's try to answer now. Because few particles are deflected back, so that's reason means the core is massive and it has positive charge because alpha particles are deflected by nucleus. So we can also say nucleus is positively charged. Next is asking you the charge actually. So as I mentioned before, as positive charges means alpha particles are deflected by nucleus. So we can say the nucleus is positively charged. So that's the reason we have written here the charge on core means on the nucleus is positive. State what occupies the space between these charged cores. So you can see here this is nucleus and this is also nucleus. Simply we can say empty space. So this is how we can answer our next question and the last one. So last one is quite a basic question. Is simply asking you need to find out number of protons and neutrons in alpha particle. So here the 2 is actually, this is called atomic number. 2 is called atomic number, and this is equal to number of protons, is equal to number of protons. So we simply write down number of protons, and the 4 is, this is actually mass number. This one is mass number. Mass number, simply this is equal to number of protons plus number of neutrons. So number of protons, quite straightforward, we can simply write down 2 protons. How about number of neutrons? Number of neutrons also 4 minus 2. So we can write down this one, we use letter Z. For mass number we use letter A. So we can write down here A minus Z will give you number of neutrons is also 2.